Hi, my name is Muhammad Shahril bin Muhammad. My ID number is TB21065. Okay, today I want to present a step or procedure of Bernoulli equation Torricelli law experiment. Okay, but before we start the experiment procedure, I would like to tell that there are some material or apparatus that we use in this experiment. Okay. First, bucket. Second is water. Third, drill, scissor, or another object to make a hole in the bucket. Fourth is ruler. Fifth is stopwatch, and then lastly, 3 meter laboratory lab chair. Sorry, my mistake. After that, now I want to explain the procedure for this experiment. First, we set the 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 distant hole from the bottom. That's meaning the distance of hole, that this hole from the bottom to the hole. We set for 1 meter. After that, we take a measurement of uh the distance s of the water flow from the opening from this hole. Uh, we run the simulation. Okay. After that, we record time taken of the water flow from the begin until stop. After that, uh, we repeat the step of our edge, the distance of hole from the bottom for 2 meter, 3 meter, 4 meter, and 4.5 meter. That's all from me. Thank you.
Assalamualaikum. My name is Ahmad Salahuddin bin Amir. My ID number is TB21069. Okay, I will cover part for safety precaution for Bernoulli labs. Okay, first, the data is taken more than 3 times each to avoid any pilot's error. Okay, for then, we use a ruler to get an accurate length of distance and stopwatch to get the estimate time of water taken to empty the bucket. This experiment must be conducted carefully since we use a sharp tool to create a hole. Lastly, for the safety precaution is be careful when we do this experiment because the water might cause a slippery floor and we can get the injury. That's all for the safety precaution. Okay, Assalamualaikum and hi. Okay, for the result of this experiment, we calculate the time and the distance between water and water. Okay, for the 1 meter, we get 89.5 seconds for the time and 8 meter from the distance. Okay, for the 2 meter of hole, we get 77.5 seconds and 7.7 meter for the distance. Okay, for the 3 meter, we get 63.2 seconds for the time and 6.9 meter from the distance between water and bottle. Okay, the second last is 4 meter. We get 44.7 seconds for the time and 5.3 meter from the distance. Lastly is for 4.5 meter. We get 31.6 seconds for the time and 3.9 meter from the distance. Okay, let's go to the how we get the jet velocity. We get is we using this formula v equal to square root 2 times g times h. G is for the gravity, H for the head. Okay, first we go to the 1 meter. Jet velocity we get 30.87 millisecond, and 2 meter we get to 7.75, and 3 meter we get 55.62, and second last we get 55.49, and lastly for 4.5 we get 62.43 millisecond. Okay, let's go jump to the graph. This is graph distance versus time. Okay, we plot this. Okay, we can see. Uh, okay. Okay, for the number 4 question is how we determine to get the jet velocity from the x component. Okay, we take the at z is a 6.9, and at exit is sorry at axis is a 63.2 second, and for the y axis we take 6.9. Okay, we take the for 3 meter for to get the jet velocity. Okay, this we use this formula is 6.9 meter equal divide by 63.2 second, and we get a 0.12 millisecond. Okay, that's all for me for the result of this experiment. Thank you.
Hi, Assalamualaikum and a very good day. My name is Adika binti Muhammad Zamri and my ID metric is TB21068. Today, me and my friend will discuss about Bernoulli principle and Torricelli law. What is Bernoulli principle and what is a relation between Bernoulli and Torricelli law? Bernoulli principle is pioneered by Daniel Bernoulli, who published a book of hydrodynamics in 1738. However, the formula has been derived by Leonhard Euler on 1752. This principle states that when the speed of light is increasing, occurs simultaneously in decrease of the flight potential energy. This principle can be used in various types of fluid flow. The one of form is valid for compressible flow. It's also required the sum of kinetic energy, potential energy and inertial energy remain the same. Then, what is a relation between Bernoulli principle and Torricelli law? Actually, Torricelli law can be derived from a Bernoulli principle which related to the velocity of fluid leaving the orifice in fluid filled container of the height of the flight above orifice. This law emphasizes that the speed of liquid flowing under the force of the gravity out of opening tank is proportionally jointly the square root of the vertical distance between liquid surface and center. The formula of equation is clearly stated as V is equal to square root 2 times 2gh or bracket 2gh power of 1 over 2. From the formula, we know the speed is attained by a drop water under the force of gravity alone, disregarding the effect of air through an opening in a tank given a distance. Below the water surface is the same with the speed attained by a drop of water falling freely under the force of gravity took the same distance. The speed of efflux is depending of flow direction. The speed is provided by this equation at the side of the opening, whether its opening is directly upward, downward or horizontally. That's all from me. Let's continue from the other group member presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sumi Amira binti Muqfazi 21067. So, for the discussion, we can conclude that how to determine the jet velocity. So, for the jet velocity, for 1 meter, we got 13.187 meter per second. So, for the 2 meter, we get 27.75 meter per second. For the 3 meter, we get 41.62 meter per second. For the 4 meter, we get 55.49 meter per second. For the 4.5 meter, we get 62.43 meter per second. So, based on the formula, we can define that the jet velocity by using the equation V same as square root 2 GH. It means a jet velocity can be simplified with square root 2 times 2 gravity and height. The height value is determined by the value of a pressure in a water. The greater the value of depth, the greater value of pressure. It is proven by an experiment that when the value of height increases, the value of a pressure also increases. When the value of pressure increases, the time taken to make a beaker empty increases. The pressure pushes all the water at the high pressure and force the water flow in a short time. Not only that, the pressure also produces a large distance from the beaker and water. In order to get the jet velocity, we need to combine the gravity value because the water falls into the initial part, that is 0 meter per second. This experiment was successfully showed a Bernoulli principle. This principle is the point of any moving liquid with higher velocity has a lower pressure. To keep the sum potential energy, kinetic energy, and pressure constant as the velocity increases, the pressure decreases. Lastly, the value of velocity inversely proportionally against the pressure value. In the nutshell, we can conclude that the aim of the lab was successful. The velocity of a fluid leaving a hole in a bottle is proportional to the height of a liquid in a bottle. The connection may be summarized as follows. If you have a liquid in a bottle with a small hole at the bottom, that liquid will leave through the hole with the same velocity as you drop it from the same height to the level of a hole. Based on the result of the experiment, if the height of a water from hole increases, the distance between the water and the bottle decreases. And when the value of pressure increases, the time taken to make a beaker empty increases. And it is proven by an experiment, when the value of height increases, the value of a pressure also increases. That's only for me. Thank you.